Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on algebraic fractions. So by the end of this video, you should be able to perform the 4 operations with algebraic fractions. Of course, I'm talking about addition, subtraction, multiplication, and division. So what makes a fraction algebraic? Well, it's like a normal fraction, except it has a pronumeral or a letter in it. And it turns out that the way that you add, subtract, multiply, and divide normal fractions with just numbers is exactly the same as what you do when you're working with algebraic fractions. So I'm going to start off by showing you how to add and subtract fractions, but I'm going to start off with fractions that just have numbers. So let's say I wanted to do a half plus a third. So remember, when you're doing that, you don't just add the top and add the bottom. That is completely wrong. What you have to do is you have to find the lowest common denominator. Remember, denominator is the number on the bottom of the fraction. You have to find the lowest number that is a multiple of both the denominators. And the reason for that is you can only add or subtract fractions if their denominators are the same. So if I want to add together a half and a third, firstly what I have to do is I have to make them have the same denominator. So what I do is I find equivalent fractions for each of these that have the same denominator. Remember, to find equivalent fractions, you times top and bottom by the same number. So for 2 and 3, the lowest number divisible by both of them is 6. 6 is the lowest number that 2 goes into and 3 also goes into. So what I want to do is I want to times 2 by 3. So if I times the bottom by 3, I times the top by 3. Then for this one here, the second fraction, I want to times the denominator by 2 to get 6. So I have to times the top by 2. So the first fraction, a half, becomes 3 over 6. And that makes sense. 3 over 6 and a half are the same thing. The second fraction becomes 2 over 6. And now you can see that they have the same denominator. So when that's the case, you only add the numerator, which is the top numbers. You do not add the denominator. You keep it the same. Okay, so don't add 6 and 6 and tell me this is 5 over 12, okay? So that's how you add or subtract fractions that just have numbers. So when we're dealing with ones that also have letters, it turns out that it's exactly the same process. So let's say I have, instead of 1 over 2, a over 2, and instead of 1 over 3, a over 3. So even though this looks different, we're going to do it the same way. So what we have to do is we have to multiply top and bottom by something, each fraction, so that they have the same denominator. So if I times top and bottom by 3 in the first fraction, it becomes 3a over 6. a over 3 becomes 2a over 6. And we do it exactly the same way. We just add the numerators, just add the things on top, and we leave the denominator as it is. So that was a pretty easy example. Let's look at an example that's a little harder. So let's look at this example here, 2a over 5 minus 7 over 5b. So subtraction has the same rule as addition in that you can only subtract fractions if the denominators are equal. And they are clearly not equal here. So one has a 5 and one has a b. So what I'm going to do is I'm going to times top and bottom of the first fraction by something so it has the same denominator. So if I times bottom by b, and I have to times the top by b as well, they will have the same denominator. The first fraction will become 2ab, denominator 5b. Okay, and I don't need to do anything to the second fraction because they have the same denominator already. And so, as I explained before, we only add or subtract the numerators. So we just go 2ab minus 7. They are not like terms, so I can't do anything with that. And we keep the exact same denominator, and we don't change them at all, okay? So that is addition and subtraction. Now let's have a look at multiplication and division. So you'll probably be relieved to know that multiplication and division with fractions is a lot easier. But the extra thing is you have to be able to cancel, which is sort of the same as simplifying. So just like when you simplify fractions like 10 over 20 is a half, you need to be able to simplify algebraic fractions. So I'll show you that first. So let's say I have something like 5x over 15. Okay, so I just want to simplify it. So simplifying, cancelling, same thing. If there is something on the top and something on the bottom that share a common factor, what we do is divide by that common factor. So what I mean by that is we can see here that 5 is on the top and 15 is on the bottom. They both have a common factor of 5. 5 goes into both of them. So to simplify this, what I do, I can divide the top by 5 because I'm dividing by 5 because that is the common factor, and I have to do the same to the bottom. What you do to the top, you must do to the bottom. So I'm dividing top and bottom by 5. So 5x divided by 5 just gives me x. 15 divided by 5 is 3. So this fraction here and this fraction here are exactly the same. This one here just has smaller numbers, smaller things in it, so it's simpler. Okay, let's say though I wanted to cancel something like this, where I had, say, 7a squared b over, let's say, 14b. Okay, so sometimes the common factor isn't just a number, it can also involve a pronumeral. So here, 7 goes into both the top and the bottom, so I'm going to divide top and bottom by 7, but b also goes into the top and bottom, so I'm going to divide by 7b. So the reason they call it cancelling is a quicker way is sometimes you can just cross them out. So b is on the top and the bottom, I can just cross them out. So then 7 divided by 7 is just 1. 7 goes into itself once, and 7 goes into 14 twice. So I'm left with, on the top, 1a squared. I don't need to write the 1, over 2. So I've simplified that. Let's look at one more example. So let's say I want to simplify or cancel the common factors in this fraction here. So 18k squared over 30k. So the highest number that goes into 18 and 30 is 6. So I can divide top and bottom by 6, right? So that's the same as cancelling. 6 goes into 18 3 times, goes into 35 times. I can also take out a factor of k squared. Okay, because there's k's on the top and bottom, so the highest common factor is the lowest power here. So k squared goes into the top and to the bottom. So k squared divided k squared is just 1. K cubed divided by k squared is just k. So I'm left with 3 on top and 5k on the bottom. So again, this fraction and this fraction are exactly the same. So cancelling is very useful and helpful when we're doing multiplications and divisions. So now I'll show you a few examples of those. So let's look at a multiplication. So let's say I'm doing something like 7 over x times by y over 5. Okay, so multiplication of fractions is pretty easy. You just multiply the top, 7 times y, and multiply the bottom, 5 times x. Okay, how easy is that? But why did I show you all that stuff about cancelling? Well, sometimes cancelling is required when you're multiplying or dividing. So let's say I have a multiplication sum like this. So what you have to do is you have to cancel and multiply. It doesn't matter whether you do the multiplication then simplify it or simplify it then multiply. It doesn't matter. So I'm going to do the latter. So what I'm saying is, from the previous slide when I was talking about cancelling, anything on the top and anything on the bottom that share a common factor, you cancel them. So let's look at 12. 12 and 18 share a common factor of 6. So 6 goes into 12 twice, it goes into 18 3 times. That's the cancelling. We have a p on the top and on the bottom. But remember, p squared is like p times p. So we can just get rid of the squared. Okay, and there's just a p on top. 5 goes into itself once, goes into 25 5 times. So on top, you're left with 2 times p times 1, which is 2p, and on the bottom, 5 times 3, which is 15. Okay, so cancelling becomes a lot more important when you have more complicated expressions. So let's look at this example here. So if we could actually multiply the tops together like that, but that would take quite a bit of effort. Instead, what we want to do is we want to cancel, simplify first, just to make this a little easier. So the way I can do that here, it doesn't look like it, but there are some common factors because I can factorize here. So this thing here factorizes because 7x and 14 have a common factor of 7. So I can write it like this. Okay, so that's just factorizing the top. You factorize the bottom as well. I can do that because 8p and 24 have a common factor of 8. So all I've done is rewrite this first fraction. I haven't done anything to the second fraction, okay? Now, the hard thing about cancelling is that you've got to cancel something that's multiplied. So I can't just cancel the 2's there because they're being added. But what I can do is cancel this whole expression and this whole expression. So they're gone. I can cancel p minus 3 and p minus 3. And I'm just left with 7 on top and 8 on the bottom. So cancelling made things so much easier. If I had to multiply like the bottoms together, I have to use FOIL. It just gets really hard and it becomes, so difficult to try and find a common factor. So when you're multiplying complicated algebraic fractions, always see if you can simplify first, if you can find a common factor. So last thing, I'll just show you some division. So let's say let's start with an easy one, 8 over k divided by a over 2. So remember, when you're dividing fractions, what you do is you flip the second fraction and make it a times. So first fraction stays the same, flip the second fraction, make it a times, and then I can just go 8 times 2, k times a. Okay, and then I'm done. Let's look at a more complicated example. So let's say I have this set of algebraic fractions that I have to divide. So same process, even though it looks different. First fraction stays the same, and I flip the second fraction and make it into a times, okay? So just like the example I did before, this would be really hard to times tops together. That'd take us a lot of effort. So what we want to do is we want to simplify this, find some common factors. So again, I'm going to factorize 4x and 12, common factor 4. 12 divided 4 is 3. And I'm going to do the same to this expression here because I can factorize it. 11p and 44 have a common factor of 11, so I take that out. So I flip the second fraction, it's a times. Again, I can cancel, that makes things easier. So I cancel the p plus 4's because they're being multiplied. I cancel x plus 3's. So I'm left with 4 times 11, which is just 44. And that answer, not obvious at all from the original question. I know this is a very hard topic. Please ask questions. This has been the luckiest maths teacher in the world. Have a great day.